Okay, so we mentioned frequency and period, right? And they do have an error with this graph in exercise 1. All right, this graph is y equals 3 cosine x. It actually should be like, let me do it in black, yeah. Should be starting up here at 3 and coming down. I don't know what happened with this page, but it should be going like this, guys. All right, should be up to 3. So you might want to make that fix in your book. Okay. All right, that's what it should look like. Now, remember, one full cycle, well, in this particular case, a cosine curve, right? It's the distance it takes to go like one cycle. So from here, and you see it finishes the cycle here, right? And then it'll just keep repeating that same thing, right? And that interval where it makes one cycle, if you remember, that's called the period, right? So the period is from here to here, right? From 0 to 2 pi. Everybody with me on that? Or we could just say the period equals 2 pi, right? And also, the frequency, if you remember, is how many times the pattern repeats in one period. And in this case, how many times is this? Oh, and this should go up, by the way. We didn't get that up. That should go up to 3. How many times does this pattern repeat itself in one period?
It should repeat itself.
Just once.
Yeah, that's one.
From 0 to 2 pi, right? There's one cycle of this cosine curve, so the frequency is 1. You with me? So let's go to part B. So this set of axes y equals 3 cosine times. So this is 3 cosine x, right? Now they want 3 cosine 2x. What do you think multiplying by 2 is going to do inside here?
It's going to multiply the period.
Right. So if we're doubling the x, won't that like effectively squish the curve, kind of like a spring or an accordion? It'll squish it tighter inside there, and maybe we'll change the frequency. So we know the 3, it's going to be the same as the one that's on there, right? Up and down 3 from the midline, okay? But then it's going to occur 2 times faster within a period, if that makes sense. So let's sketch that one. I'll do green, right? So it's still up 3, right? But now, like instead of hitting the axis here, right, we're going to hit it here. Follow me? And then down to here. So we're kind of squishing it in. Like twice as many of these things in one period. There, and then there, right? And then halfway, and then up here, right? And if we go to the other side, right, it'll be there. Oops. Down far enough down here, right? And then we're going to hit, what else are we going to hit here? We're going to hit here, right? And then up 3, down there, and down 3, and then there, and then back up here, okay? So here's the graph of 3 cosine 2x. See how it kind of squishes it in a little tighter? It's really sloppy. Sorry, guys. This is harder to do than you think on a smartboard. At least I'm not making any V's. Okay? So notice what happened here. If we look at this same single period from 0 to 2 pi or 0 to 360, how many times does the cycle repeat itself? Now,
It will repeat itself twice.
Twice, right? How many full cycles? So it's 2. 2 full cycles, right? So that means that the frequency f equals 2. And the period is the same. It's still a period of 2 pi. right? That distance from 0 to 2 pi. Does that make sense? So we doubled the x's in here, which means we doubled our frequency. If that was a musical note and we doubled the frequency, what do you think it would do? Like the
It
sound
would
wave.
speed it up.
Not speed it up. How would it make the musical note sound if frequency was increased? Any musicians out there, band or anything? Does anybody here play an instrument in band? Olivia, you do. What do you play, Olivia?
Flute.
Flute? Okay. And when you're blowing over the flute there's some vibrations that go on, right?
Yep.
And that's the sound waves. And if you close up some holes on the flute, the frequency increases, right, of the vibration, and what happens to the sound? The pitch.
The pitch gets louder or higher.
Higher, not necessarily louder, right? You can still play it quietly, but the pitch will go, a note higher, right? Okay. So that's what the frequency is. Like the more times this curve shows up within a period, the higher, if you think of it as a sound wave, the higher the note will be. Now the 3 out here, this is where you're playing it louder, right? So if you multiply the amplitude by 3, it's louder. And then there is the frequency. So it's higher. Does that make sense? Okay. Let's look at the next one here. Sketch a graph of y equals 3 cosine of 1/2 x. So we still have 3 for our amplitude, right? But what do you think this is going to do to the curve?
It would half it, meaning that there's going to be only 1/2 of the period.
Yeah, wouldn't it reduce the frequency, right? So let me do this maybe in red, okay? So we're still going to start up here, okay? And if you like, you could do it like a table of values on your calculator. That might be helpful, right? But originally, like we would have come down and hit here, right? But now we're not, are we? Where are we going to go? Out to here? Well, you can't even see where I'm pointing at, right? Like that. Okay. And then down to the 3 here. So you see what's going on here? Whoops. Like that. Okay. And then this one will kind of come out here, right? Like this. So they kind of look like that. So this is y equals, what was it, 3 cosine 1/2 x. You can read that. Okay. And the other one was, what was it, y equals 3 cosine 2x. This is y equals 3 cosine 2x. So what happened? So the period's the same, right? Well, no, the period's not quite the same, is it? How many full cycles did it do from 0 to 2 pi now? It did a half cycle, right? It did a half. Okay. So our period is different now, isn't it? But what's the frequency?
Frequency is 1/2.
Right, frequency is 1/2. Okay. With me on that? And what's the amplitude, by the way?
Amplitude is 3.
Still 3, right? That's like the volume. Okay. So we're talking about the period, right? That's the number of times a cycle happens, right? Or it's the distance it takes for one cycle to happen, okay? They call it the minimum horizontal shift right before it repeats itself. So basically, the basic, with no multiplication or addition, basic sinusoidal graph periods are 2 pi, from 0 to 2 pi. It'll happen one cycle, okay? And we know that multiplying by something out here like that A changes the amplitude. And this changes the what when we multiply inside? We just looked at it. The frequency?
The frequency, yeah.
Yeah, okay. So this b, whatever you're multiplying by, that you can call the frequency of your curve, okay? If you're multiplying x by something inside the function, you can just say that's my frequency, okay? So let's look at some examples here. So exercise 2, y equals 3 cosine x. All right, so what is the frequency of this function?
1.
It's 1, right? Because there's a 1 in front of there, isn't it? God darn it. Because there's a 1 in front of there. And what is the period?
2 half, 2 squared, 2
2
pi.
pi, right? Why, why world of sports? 2, you guys are seeing this, right? 2 pi, good grief.
Wait, does the pi actually change? Does the period ever change?
It does, yeah, right? We're going to see that in a second here. And by the way, let's add this. What's the amplitude of this function?
The amplitude is 3.
3, right? That's the volume. All right, let's look at the other one. Y equals 3 cosine 2x. So what is the frequency of this function?
Frequency is 2.
2, right? But now the period, the time for it to do one cycle, if the cycle happens twice, right? What happens to the period?
The time.
I might have written it wrong up here. Let me just go back up here real quick. I think I wrote this wrong. I did. This period here. Look at the green graph. Right? What distance did it take to get one full cycle?
1 half.
Well, just pi, right?
Yeah, just pi.
0 to pi. So I did write that wrong there, right? The frequency doubled, so the period got smaller, right? So they're like inverse of each other. That's what I was getting at. So if the frequency here in y equals 3 cosine 2x is 2, the period is normally 2 pi, right? Right? Normally the period's 2 pi. God bless America. I'm going to throw this smart word right out the window. What's the period now if we double the frequency? Instead of 2 pi, it's what?
It would just be pi.
Half of 2 pi, which is just pi. Okay? Let's look at C. 3 cosine 1 half x. What is the frequency?
1 half.
1 half. Right? Which means we have to double the period, right? The time for a cycle to happen, right, gets doubled. So instead of 2 pi, what is our new period?
The period is
Double
4.
it. 4 pi.
Yeah, 4. Also, you did not change. Also, number D.
Yeah, look up here. I didn't even write it
Yeah,
down
you
there.
didn't
Yeah.
note that.
But look at the green graph there, right? Or we did the red one. The red one.
It takes
Right?
longer.
It takes longer for a cycle to happen, right? It's going to goes to the end of the graph, right? It would have to go out to 4 pi to finish that cycle. So the period and the frequency are inverse of each other, right? So if the frequency goes up, what happens to the period?
It's lower.
It goes down. If the period goes up, what happens to the frequency?
It goes,
Down.
yeah, it goes longer.
Yeah. So if I triple the frequency, I cut my period in a third, right? Okay. Let's look at some examples on the next page. So for example, the frequency and period are inversely related, right? So to be inversely related, you probably remember from algebra, the period equals 1 over the frequency. Or you could say the frequency equals 1 over the period. So let's say, just to clear that up, let's say that we double our frequency, right? We multiply the frequency by 2. Then the period is 1 half of that. Does that make sense? Or if we double the period, the frequency is 1 half. Okay, they're inversely related, right? So examine the results from exercise 2. What's true about the period P and the frequency B, right? Well, let's look at one of the periods, right? For the y equals the 3 cosine x, right? The first period was just 1 times 2 pi, right? Which is 2 pi, is it not?
Yes.
And then the second one we did, right? It was, the frequency was 2 times its period was pi, right? Which gives us, again, 2 pi, doesn't it? But the other one where it was 1/2 and the period was 4 pi, what's half of 4 pi?
2 pi.
Right? So they always come out to the same, right? It always washes out when you multiply them, because one of them is the reciprocal of the other. So in other words, period times frequency equals 1 full cycle, right? I'm considering these like 1, right? Because they're like the whole thing, if that makes sense. And if we solve this for period, right, we divide by f, you get period equals 1 over f. Or if we go and solve it for frequency, divide both sides by p, 1 over the period. Okay? Let's look at some examples, see if we catch this here. Determine the period of each of these. So we need the frequency, right? So let's take it y equals 6 sine x, 6 sine of 4x. What is the, what's the frequency here?
Frequency is 4.
So the frequency is 4, right? Which means the period is 1 over 4. So the period is just the fourth. You following me? And what's a fourth of 2 pi?
1/2.
1/4 of 2 pi, right, is 1/2 pi. So period equals 1/2 pi. Does that make sense? Let's look at part B. What's the frequency?
1 ส่วน wait, no, pi ส่วน
Pi over 3, right? So the period equals 1 over pi over 3. Now, you know what happens when you do that, when you take a fraction and put it in the bottom?
it times it.
That's the equivalent of this, 3 over pi. 1 over something just gives you the reciprocal, right? And then if we do 3 over pi times a normal period of 2 pi, the pi's cancel, and what do we get?
6 pi.
6. No, the
Six.
pi's cancel. It's 6 radians, right? And this would be radians over here. Okay? Let's try part C. The frequency is what, guys?
2 ส่วน
2/3. The period is 1 over 2/3, right? So 1 over 2 over 3 actually equals what, everybody? What's the reciprocal of 2 over 3?
3 over 2.
3 over 2, right? So basically, period and frequency, you just flip the fraction, right? So let's do 3/2 times a normal period of 2 pi, right? 3/2 of that. And what do we get? 6 pi over 2, which is what?
That's 3 pi.
3 pi. Radians. All right? Is anybody confused there? If you know the frequency, you basically just flip it to get the period, and vice versa. All right, let's do exercise 5. So they want us to sketch the function y equals 2 sine of 4x. So the frequency here is what?
Frequency is 4.
I'll do it down here. So the frequency is 4, right? Which means that the period is what? What's the reciprocal of 4? 4 over 1. What's the reciprocal of 4 over 1?
1 over 4,
1/4 of a normal 2 pi, right?
and that'd be 1/2.
1/2 what?
1/2 pi.
Which is pi over 2 radians. So that, right? So from 0, oh, they didn't put them in here. Jeez. So from 0, and this should be pi over 2. So let's put these in. Pi over 2, that must be a typo, right? And then we have pi and then 270 is 3 pi over 2. And here's 2 pi, and it's negatives on the other side, right? So now between here and here, right, that's our new period. So the whole cycle takes place within that, doesn't it? Up here. Which means our frequency quadrupled, right? So we're going to squeeze 4 of these cycles inside here, aren't we, right? So what's the amplitude, by the way?
Amplitude is 2.
2, right? So we're still going to start here, right? But instead of going up 1, we're going to go up 2, aren't we? Right? Is this sine x? Yeah, we're going to go up 2. But it's all going to happen between here and here, right? So this gets a little tricky. So we're going to go up like to here, right? Down to here,
How long did the
like this. Oh, I got to go up 2.
amplified?
Yep, sorry, I got to go up 2. This, I swear to, oh, that's holy, the stupid thing. We got to go up 2, and then there, and then here, and then there, right? And then up 2 again. Down, down 2, and then here. So you kind of see what it's doing? We go up, squeezing 4 of them in here. Like that. And I won't do the negative side. You get the idea, right? So the frequency happens 4 times. Let's count it here, right? So here is our first cycle, right? Here's our second cycle. There's 2 so far in 2 pi. I don't know. Give me a different color here. Maybe like that. Who knows? And here's our third cycle. I don't know if you can see that. Not too well, huh? And then we're going to have another cycle. I'll use pink, I guess. I don't know. Right? So do you see we have 4 cycles happening in 2 pi? That means the frequency has been multiplied by 4. Frequency is how often does something happen, right? 4 times. Does anybody have any questions on this? Remember, now's the time to ask. All right, we're going to skip exercise 6, and I'll just go right to giving you your problem set. Shouldn't be too much text out. So your problem set, not going to be too much. Number 1, 2, A, and C, 3, 5, and 7. Okay? Any questions on this frequency and period? All right.